If you keep telling yourself you can't build your own gaming PC, then you'll probably always believe that. But you see this sexy thing right here? This is a one-of-a-kind custom gaming PC, totally spec'd out to my liking, and guess what? It was my first time even building a PC. Were there some hiccups along the way?
Oh,
It's
I see
smoke.
smoking.
Yeah, but the reason that I'm making this video is so I can show you guys what to expect along the build journey, and believe me when I tell you that it's a lot easier than you might think. The very first thing before I even purchased a part or placed in a screw was understanding the different components that made up a PC. So the RAM, the CPU, what type of storage options are out there, what about power supply, fans, all-in-one cooling system, motherboard, the list goes on. It's very important to understand the why for the different parts that you're going to be purchasing and then later putting together. One of the sites that I used to at least pick out the individual parts that I was going to select was PCPartPicker.com. This isn't a sponsor for them, but this was a good fundamental site that I used to help look through the different PC parts that were available out there to purchase on places like Amazon, Newegg, Best Buy, as well as seeing the reviews attached with those. So that way I knew I wasn't getting a part that maybe was subpar. The other thing to this website is that it allows you to pick parts that are all compatible with one another. That's very important when building a PC. And as I was waiting for all of my parts to arrive, I took the additional time to research and understand as much as I could about how these components would be put together. Once I got all my PC parts in, I first started off with the motherboard. This is the X870 Eagle Wi-Fi 7 motherboard that is compatible with the AM5 CPU socket type. The CPU we got to fit that socket is the AMD Ryzen 7 7700X. It has 8 cores and a base speed of 4.5 gigahertz. To install the CPU onto the motherboard, you're first going to need to pull the lever you see here to unlatch the CPU mounting plate. Then grab the CPU, being very careful not to touch the pins on the bottom, and place it onto the motherboard without pressing down on it, as that can also damage the pins. Now you can latch the CPU on and you'll see the mounting plate pop off. Next, we'll be installing two 16GB sticks of Corsair's Vengeance RGB DDR5 RAM. One thing you'll notice on this motherboard is that there's 4 DIMM slots for RAM, so you're going to want to use slots 2 and 4, which should be labeled as DDR5A2 and B2 on the motherboard. And this is to enable dual channel memory, which optimizes the performance of your RAM when using 2 modules. To set the RAMs, unlatch the top ends of the slots and just slide them into place, making sure the contact pins line up with one another. If you do this correctly, you'll hear a click once it's into place. Now make sure you guys keep watching until the end, as I'll show you how you can max out the speed of your RAM, as it's not something that's set up by default. Next, I picked the Samsung 990 Pro NVMe M.2 2TB SSD. To install this, first find the M.2 drive spot on the motherboard and remove the heat shield via the latch. Then you can line up the connector pins going in at an angle. Once the drive is seated into place, put the heat shield back on and relatch it. Now that we had our CPU, RAM, and storage placed onto the motherboard, it was now time to get the case that this would all fit in, which you see right here, and this is the Corsair 3000D RGB Airflow case. After taking this out of the box, I set the tower on its side, so that way I can easily put the motherboard into the case and line up the screw spacers between the motherboard and the case. Now, one thing to note, especially with this motherboard, is that it already has the IO shield placed on the back. So there isn't that additional flimsy part that you might see in other builds that has to be pre-placed before putting in the motherboard. It's already on the motherboard, which is why it's such a good board. So with that all lined up, it was just a matter of putting in the 9 screws to securely place the board into the case. Up next, it was time to detangle the wires that came with the case and get those plugged into the motherboard. Now, I'm not gonna go super in depth on these cable connections, but I will give you guys a quick rundown. So if you take a look at the cables on the left side here, you will see that they match up to the motherboard headers in the diagram on the right. For my setup, I had to plug in the audio and USB 3.0 cables. The other two my case didn't come with. Now the front panel cables are these four little buggers, which are called the JFP1 cables, which have to be plugged in the following pattern in order for things like the power button and its lights to work properly. But the trick I kept in mind here was to make sure that the text was facing down. That way it would be connected right, and I'd also be following the appropriate pattern correctly too. The cables that you see to the left of my JFP1 connectors are plugged into the sys fan headers 1 through 3, and this is to power the fans that are in the case. As for the RGB lighting that works with these fans, that's powered by a 5-volt 3-pin RGB light connector that can be plugged into any one of the two RGB headers on the bottom left of the motherboard. With the case connectors plugged in, it was now time to set up the primary power delivery system that this computer would leverage. And this is where the power supply comes in. The one you see here is the Corsair RM750E fully modular power supply, meaning there are no fixed cables attached to it. The cables we'll want to connect though is first the motherboard cable. This cable has the most pins out of all of them, so you honestly can't miss it. It has 24 pins. The split end of this cable will plug into the power supply and then the other end into the motherboard on the right side. Next, to power the CPU, you'll want to use the EPS 8-pin connector, which is often labeled as CPU, with one end going from the power supply and the other end into the CPU power slot on the top left side of the motherboard. The last power cable is the 12-volt connector cable for the GPU. And the GPU I decided to go with was the Gigabyte GeForce RTX 5070. It's a fantastic choice for high refresh rate gaming in 2K and 4K quality, as well as recording in OBS Studio, which I'll show you guys some sample gameplay in a moment. But to install the GPU, using a screwdriver, we need to remove the two PCI brackets for where our GPU is going to sit. From there, make sure the GPU and motherboard connectors are lined up and push it into place. After that, the GPU can be secured using the screws that were used for the PCIe brackets. Now we can go ahead and take that 12-volt connector that we already plugged into the power supply and connect the other end of that cable into the front of the GPU. Now, one item that I haven't mentioned yet as a part of this setup, you guys may have seen it anyways in some of the B-roll I've shown in this video, but that item is the CPU cooler, and I decided to go with an all-in-one cooling option. The ones I went with were the Corsair iQ Link Titan 240RX RGB, but hold your horses, I'm not getting into how this thing was set up because watch what happened. It's time for the moment of truth. Will this computer work after all of this work? We're about to find out in 3, 2, 1. Oh, it's smoke.
It's smoking.
All right.
Turn it off.
Is it still?
Turn it off, turn it off, turn it off, turn it off.
Guys, this was definitely a scary situation in the moment because my girlfriend and I, we had no idea what created the smoke and pop from my PC. But for this being my first build, I was certain that maybe I plugged in something wrong. So that's why I went ahead and took my time to troubleshoot, and I was able to narrow down the issue to the Corsair AIO cooling system. So suspecting that I just had a faulty unit, I got another one shipped out to me, and well, 3, 2, 1. These didn't turn on still though. I don't smell anything funny, do you? What the heck is going on? The sync module that's used to power these fans, it blew again. So at this point, I'm left with no choice but to completely remove these fans from my setup, clean off the old thermal paste using rubbing alcohol so that we could give the NZXT Kraken 240 AIO cooling system a try. This one came with the two fans detached, so they needed to be screwed onto the radiator. One point of caution before mounting your fans and radiator to the top of the case, make sure you plug in the CPU fan header. If you do this in reverse, it's gonna be really hard to plug that little cable in at the top of the motherboard. The rest of the cables were connected by following this diagram from NZXT that you see on screen, with the power delivery handled via the SATA connection from the power supply. Last step of installing the AIO was securing the cooling component over the CPU using the AMD AM5 mounting bracket and screwing the fans to the top of the case. Now that we had an actual fan and cooling system a part of the build, it was now time to do an official first boot. With a keyboard and mouse connected, a display connected to the graphics card, not the motherboard, the power supply plugged into the wall, and switched to on. Please, no smoke. Please no fires. This has to work. Here we go. 3, 2, 1, fire up. What do we got? What do we got? No smoke. The fans are going, guys. Let's peel this off. What you guys will see upon your first boot is your BIOS menu, which is essentially firmware to help initialize and configure the hardware components a part of your build. For example, you can go into your fan settings and set custom control speeds. The BIOS is also where you can overclock your RAM. To do this, you're going to want to head over to the tweaker tab and find the extreme memory profile below and enable this. In the future, if you need to get back into your BIOS, you can just spam press the delete key upon boot. The next thing to do was to grab an empty, at least 8GB flash drive, format and turn this drive into a Windows 11 boot drive. To do this, you're gonna need to use a different working Windows computer and go to the Windows 11 software download page where you can select the download option under the Create Windows 11 Installation Media. Once you have that downloaded, you'll be able to launch it and turn one of your USB drives into a bootable one. Next, plug that drive into the new PC, and when you boot, it should automatically detect the Windows installation files. From here, it's just a matter of installing the OS, which will require internet. That's why you see me with this Ethernet cable being stretched to the PC. But if that's not a feasible option for you, you can always use a Wi-Fi adapter. Once Windows is installed on your build, you're gonna wanna get a license key. I recommend VIP CD key, where you can get one pretty cheap so that you can fully activate Windows. This site is not a scam, and these keys do actually work, as you can see in my case. Also, don't forget to install your drivers. It's very important. It literally makes everything run the way that it needs to. The main drivers you're gonna need are for the motherboard, which can be installed using the Gigabyte Control Center software, and the graphics card drivers, which can be installed using the NVIDIA app. But now, having the full confidence that everything is working as it should, I performed a cleanup exercise with the computer booted down to secure the power supply and put the back panel on this case. The last component I added to this build was the AverMedia Live Gamer 4K 2.1. This is an internal capture card that connects to the computer via the PCIe slot on the motherboard. This device paired with the 5070 GPU as the video coder within OBS Studio. I was able to capture flawless looking 4K 60 gameplay, all while playing in 4K 120 on the PlayStation 5. This was something I was never able to achieve using my M1 Max MacBook Pro and even my older mini Windows computer with the 2060 in it, which is now bricked, but that's another story. In addition to capturing gameplay, this computer absolutely ripped playing games like Fortnite, Marvel Rivals, Rocket League at a high refresh rate in 2K, 4K quality using high settings. But I will say one thing that I did come across was screen tearing, which basically makes your gameplay look like it's ripping apart on screen when you're moving around. So making sure that the monitor's refresh rate and the game's refresh rate match is very important to alleviate this issue. Overall, guys, this was an exciting build to put together that got me outside of my comfort zone from buying only pre-builts and laptops. As for the price that this custom build ended up costing me, it was a total of $2,051.99. So this has definitely been my most expensive video I've done on the channel to date. But either way, I'm certain that the level of performance I'm getting out of this machine will be sufficient to last me for years to come. Now I'm gonna have to deal with the struggle of choosing between playing on my PS5 or PC. Which one do I choose? But I hope you guys could see throughout this video that everything is relatively straightforward, especially with the right motherboard. It's honestly made for you not to mess up. If you guys are interested in building my PC setup, I put links in the description to all of the parts that we configured within this build. Thank you guys for staying to the end of the video. Like, subscribe, all that good stuff. I'll see you on the next one. Peace.